Welcome to a quiet corner of the night, here with Dreamtime Science. Envision a cozy study, warmed by the amber flicker of candlelight, where the delicate rustle of flipping pages mingles with the hush of the world outside. You've arrived just in time for a peaceful voyage, one that carries you gently between waking and dreaming. If you find comfort in these stories, a gentle tap on the subscribe button would share your presence with us, and a comment telling us from where you listen would be a quiet gift. Now, ease yourself back into your resting place. Invite the cool softness of your blanket. Let your breath flow deep and calm. Together we will slowly unveil wonders meant to cradle your mind and ease your heart. When you are ready, we'll begin, slowly, softly, simply. Tonight we'll glide very slowly, very gently through the quiet shimmer of the night sky, keeping a safe, pillow-soft distance as we explore everything you could possibly know about stars. Like tiny lanterns whispered into the velvet dark, they invite our wonder and curiosity, softly twinkling secrets of the cosmos just beyond reach. Let's drift together into this gentle, starlit journey, where mysteries unfold like lullabies in the hush of night. If these gentle explorations bring you comfort, a quiet like or subscription would mean the world to me. Your support helps keep these peaceful journeys flowing. Take this moment to settle in. Wrap yourself in comfort, release the day's weight from your shoulders, and let your breath become as gentle as starlight. Night falls, and with it the world beneath you softens, dissolves, and drifts into darkness. Above, the sky unfurls an ancient tapestry woven with pinpricks of light. For as long as humans have gazed upward, these distant fires have kindled both comfort and curiosity. Their silver whispers, scattered across the velvet, have been more than mere ornaments. They are stories, guides, omens, and promises, flickering through the ages. Pause, and let your mind drift to a time before artificial glow, when the night was truly dark. The stars, then, were not just a backdrop, but a presence. In the hush of a world without electric hum, their brilliance was overwhelming. Ancient peoples, lying on cool earth or drifting in open boats, found their eyes pulled upward, their thoughts spinning outward into the deep. Among the earliest tales told by firelight, stars are woven with the bones of gods and the hearts of heroes. In Greece, the night sky became a mythic atlas. Orion the hunter strides across the heavens, forever pursued by the scorpion who brought his end. Cassiopeia sits in her celestial throne, vain and beautiful, while Perseus soars nearby, his triumph and his monsters preserved in the sky, each constellation a chapter, each pattern a riddle or a warning. But this mapping of myth is not unique to any one continent or tongue. For the Maori, Matariki, the Pleiades, signals the new year, a cluster whose annual return marks rebirth and remembrance. The ancient Egyptians saw in Sirius the goddess Sopdet, whose heliacal rising foretold the flooding of the Nile. the river's life-giving pulse, echoing the rhythms of the stars. Every culture, it seems, has gazed upon this spangled mystery and found in it something of itself. The Norse looked to the night and told of the Milky Way as the road of souls, the Bifrost bridge arching between realms. The Lakota called the Milky Way the pathway of departed spirits, and in these stories the stars are not only above but within, carrying the memories of ancestors, the breath of gods, the cycles of life and death. Stars have guided not just mythology, but journeys. Picture a Polynesian wayfinder, standing at the prow of a voyaging canoe, the salt wind sharp and the sea endless. He knows no compass but the one written in the sky. Each star rising and setting tells of a direction, a place, a promise of land beyond the horizon. The Polynesians learned to read this celestial map with astonishing precision, using the concept of star paths, memorized arcs traced by the rising and setting of stars, to cross thousands of miles of open water, linking scattered islands with invisible threads. Their knowledge was mnemonic, poetic, sung and remembered, a living star chart passed from master to apprentice, woven with story and song. Elsewhere, Arab astronomers named the stars of the desert sky, their language still echoing in names like Betelgeuse and Aldebaran. The Bedouin, too, knew the sky intimately, navigating beneath its dome, finding their bearings by the unwavering North Star, Polaris. In the Arctic, the Sami called the same star Pohjanasti, the nail that holds the world in place, constant and trustworthy in the turning heavens. For mariners, the stars were more than myth, they were survival. The sextant and the almanac, the tables of declination and right ascension, became tools as vital as the sail or the anchor. The chronometer, keeping perfect time, unlocked the secret of longitude, but it was the stars, always, that marked latitude, that drew invisible lines across open water and taught sailors to trust the heavens more than the fickle sea. Yet even as science grew more precise, the stars kept their romance. The heavens were a clock and a compass, but also a theatre. In times of uncertainty, people looked upward for reassurance. During wars, in trenches or on the decks of ships, men wrote home about the comfort of seeing familiar patterns above, Orion's belt, or the dippers shining on as they had shone for ancestors centuries before. The stars, in their cold distance, have always seemed both impossibly far and intimately close. They are witnesses to our stories, indifferent yet eternal, a silent audience to the drama of our days. And so they became not only navigational aids or mythic canvases, but metaphors. Lovers have exchanged promises written in the stars. Poets have mapped longing and fate among the constellations. The phrase star-crossed lovers, drawn from astrology, lingers in our tales of tragedy and hope. With the turn of the 20th century, a new kind of myth-making emerged, forged in the crucible of science fiction. Now the stars were not only the backdrop for gods and demigods, but the stage for humanity's own imagined futures. The genre's golden age shimmered with stories of rocket ships and alien worlds, of interstellar empires and cosmic mysteries. The stars became destinations, not just distant lights, but places to go, realms to conquer or to call home. It is here, in the realm of science fiction, that the stars began to whisper of possibility, a promise not of what is, but of what might be. The opening crawl of Star Wars, its yellow text receding into a field of stars, begins a long time ago in a galaxy far, far away. It is not a promise of the future, but a legend, a fairy tale set in the vastness of space. Other epics follow, from the voyages of the Starship Enterprise to the odysseys of Battlestar Galactica, each weaving the stars into their stories as both setting and symbol. Such tales transform the night sky, no longer only a map for navigators or a mythic stage. The stars become an invitation to dream of travel and encounter, of encountering the other, of finding ourselves changed by the vastness. The silence between stars, once a place for gods, now holds the unknown, alien life, cosmic mysteries, the secrets of time and space. Yet these dreams are not untethered from the past. Even as we imagine warp drives and wormholes, we borrow the language of old. Starships are christened with names like Odyssey and Endeavour, carrying forward the spirit of exploration that once sent Polynesians across the Pacific or Vikings across the Atlantic. The constellations, mapped anew in digital charts, remain familiar. Orion's belt, the Pleiades, the Dippers, guides in more ways than one. Science too has its poetry. Astronomers name stars with catalogue numbers and spectral types, yet often revert to the language of myth when a new world is found. Kepler 452b, dubbed Earth's cousin, or Proxima Centauri, the nearest star. The Hubble Space Telescope peers into the heart of the Orion Nebula and finds clouds of gas and dust. But in the images we see dragons and pillars, cosmic eggs. The language of the stars, even now, is half science, half story. Think of the Voyager probes launched in the 1970s and now drifting beyond the edge of the solar system. Each carries a golden record, etched with music and greetings, a message for whatever intelligence might find it. The record's cover shows a pulsar map, a diagram using the precise frequencies of distant neutron stars to pinpoint the location of Earth. Even as we send our science into the stars, we lace it with the hope of connection, the echo of myth. The stars are both a destination and a beacon, a place to send messages in bottles cast out on a cosmic sea. Our fascination with the stars is also a fascination with time. When you look up, the light that reaches your eyes is ancient. The glow of Sirius began its journey 8 years ago. The light of Betelgeuse left before the First World War. Some photons are so old they predate human civilization itself. To gaze at the night sky is to see the past made present, to look into the deep well of cosmic history. For the ancient Greeks, this was a source of wonder. The stars were unchanging, a model of perfection. Today, we know they are born, live, and die, but the sense of awe remains. Children make wishes on the first star they see at dusk, entwining hope with the physics of light. Starlight, star bright, first star I see tonight. The rhyme is an incantation, carrying forward a legacy of longing that is both personal and universal. The act of wishing is itself a kind of navigation, a gesture toward the unknown, a declaration that even in the vastness we are not alone. Even now, as city lights wash away the brilliance of the night, we seek out dark places to recover the stars. Astronomers and enthusiasts travel to mountaintops and deserts, to places where the sky is once again black and deep, and the stars return in their full glory. In such places, the Milky Way is a river of light, a band of silver dust stretching from horizon to horizon. To stand beneath it is to feel both small and infinite, rooted in the earth, yet adrift among the galaxies. Art and science entwine in this pursuit. The earliest cave paintings include dots and clusters that may be star maps. Medieval manuscripts are adorned with swirling constellations, illuminated in gold and blue. Today, astrophotographers capture the sky in long exposures, revealing colors and patterns invisible to the naked eye. Each image, each painting, each story is another thread in the tapestry, another attempt to capture what the stars mean to us. Yet for all our stories, the greatest truth about the stars may be their silence. They do not answer our questions or respond to our longing. They shine, indifferent and eternal, outlasting empires and eras, a quiet backdrop to every human joy and sorrow. Their light is a language without words, a whisper that invites interpretation, but offers no reply. Still, we listen. We build radio telescopes to catch the faintest murmurs from distant suns, seeking signals of intelligence, echoes of life. We chart exoplanets, dreaming of worlds that might circle other stars, imagining skies where 2 or 3 suns set together in crimson and gold. The search for meaning in the stars has not ended. It has only grown deeper, more urgent, more boundless. As you drift now, feeling the gentle pull of sleep, let your thoughts spiral outward, following the threads of myth and memory, science and story. The stars above are not only distant spheres of burning gas. They are companions and muses, navigators and witnesses. They have guided us, inspired us, and haunted us since the first human eyes turned upward, searching for answers in the night. And even as our understanding grows, the stars continue to whisper, their message as mysterious as ever. In their light, we see echoes of our oldest stories and hints of futures yet unwritten. The journey through their mysteries has only begun, and the night is long, filled with soft, persistent questions, shimmering just out of reach, waiting to be heard. Drift now, if you will, from the wide open dark of the universe into the very hearts of those luminous islands you saw scattered across the indigo ocean, where once you gazed at the night sky and saw a tranquil scattering of lights. Let your mind's eye draw closer, as if travelling on a silent current, until the stars themselves swell and resolve before you, not as mere points, but as worlds of blazing complexity. A star to the casual glance seems simple, a flickering pinprick, serene and unchanging. Yet behind that gentle shimmer lies a paradoxical truth, for every star is a cauldron, a cosmic forge, where matter and energy intertwine in an endless, intricate ballet. The twinkle is a deception, born of distance and atmosphere. The reality burns with a violence and grandeur almost beyond imagining. Begin with a star's birth, deep within veils of cosmic dust and gas, the stellar nurseries. These are not tidy laboratories, but enormous turbulent clouds, sometimes hundreds of light years across, where time itself seems to slow and hush. Within these clouds, gravity whispers its persistent invitation. Over vast epochs, tendrils of gas, mostly hydrogen, speckled with helium, and the faintest traces of heavier elements, drift together, drawn by their mutual attraction. As the cloud fragments, knots of matter form, growing denser and hotter, compressing under their own weight. In one such knot, a critical threshold is quietly crossed. The temperature soars to millions of degrees. The pressure mounts until atoms are squeezed so tightly that at last their nuclei begin to fuse. This is the ignition of a star, a process as inevitable as it is astonishing. Hydrogen atoms, each a simple proton, collide and merge, forming helium and releasing prodigious amounts of energy in the process. This is nuclear fusion, a reaction so potent that in a single second our own sun fuses some 600 million tons of hydrogen, converting 4 million tons of that mass directly into energy. A star is born, not with the gentle light of a candle, but with the triumphant detonation of a nuclear engine set to burn for billions of years. The delicate balance between gravity and pressure defines a star's existence. Gravity, relentless and inward, seeks always to crush the star into greater density. Fusion, outward and radiant, pushes back, creating a dynamic equilibrium. In this tension lies the star's apparent serenity, a peace earned, not given. But though the underlying physics are elegant, the variety of stars that emerge is dazzling. They do not all burn with the same intensity, nor are they cast in a single mold. The universe, in its abundance, produces a menagerie of stars as diverse as the clouds from which they are born. The majority are modest, like our Sun, a so-called G-type main sequence star, golden and steady. Yet most stars are smaller and dimmer still. The red dwarfs, those quiet, long-lived embers of the cosmos. These stars, cooler and less massive than the sun, burn their fuel with frugality. Their light is soft and ruddy, their lifespans astonishing, trillions of years, outlasting the universe as we know it. If the cosmos were a garden, red dwarfs would be the hardy perennials, thriving in quiet corners, overlooked but enduring. At the other extreme, there are the blue giants and supergiants, titans of light and energy. These stars, many times the mass of our sun, live fast and die young. Their cores burn with such ferocious heat that fusion proceeds at a breakneck pace, producing heavier and heavier elements in a matter of millions, not billions, of years. Their light is searing blue-white, their luminosity dwarfing all else in their vicinity, yet their brilliance is fleeting. In the cosmic dance, they are the meteors, flaring bright and vanishing soon. Between these extremes are yellow and orange stars, white-hot sub-dwarfs, and even more exotic types, each defined by its mass, composition, and evolutionary path. The color of a star, far from being an accident or a trick of the atmosphere, is a direct revelation of its temperature. Hotter stars shine blue or white, their surfaces reaching tens of thousands of degrees Kelvin. Cooler stars glow orange or red, their light mellowed by lower temperatures. Our sun's gentle yellow is a middle note in this cosmic spectrum. Yet for much of human history, the subtlety of this palette was concealed. To the unaided eye, all but the brightest stars seemed white, their hues washed out by the vastness of space and the limitations of our senses. Only with telescopes and careful observation did astronomers begin to discern a spectrum of color, and from there to decode the secrets of stellar physics. A star's color is not merely an aesthetic trait. It is a window into its soul, hinting at its age, size, and the processes raging within its heart. There is a mythology, persistent and romantic, that stars are eternal, unchanging sentinels above the world. But the truth is more poignant. Stars are mortal, their lives governed by a cycle as inexorable as any on earth. From their birth in nebular cradles, through long epochs of stability, to their dramatic ends, stars pass through stages as vivid and varied as any living thing. For a star like our sun, the journey is measured in billions of years. After a long period on the main sequence, fusing hydrogen into helium in its core, the supply of hydrogen dwindles. The delicate balance falters. Gravity begins to win, compressing the core, which grows hotter and denser, while the outer layers expand and cool. The star swells into a red giant, its diameter increasing hundreds of times. In this phase, the sun will one day engulf the inner planets, its light reddening as its outer envelope grows tenuous and diffuse. Within the core, new fusions ignite, helium into carbon, perhaps even heavier elements for the most massive stars. Each stage is shorter and more volatile than the last. Eventually, for stars of modest size, the outer layers are gently shed, drifting away as a shimmering planetary nebula, while the core contracts into a white dwarf, a cinder, hot and dense, slowly cooling over eons. This is a star's quiet retirement, no longer burning, simply radiating away its stored heat, destined to fade into darkness. For massive stars, the end is more violent. Their cores, unable to withstand the relentless crush of gravity once fusion ceases, collapse in an instant. The outer layers rebound in a cataclysmic explosion, a supernova. In that flash, a single star can briefly outshine an entire galaxy, hurling heavy elements into space to seed future generations of stars and planets. The remnants may become neutron stars, city-sized spheres of unimaginable density, or, if the star was massive enough, collapse further into a black hole, a singularity from which not even light can escape. Thus the universe is not populated by uniform, everlasting lanterns, but by a cast of characters, each with its own arc of birth, life, and death. The gentle twinkle is a mask. The reality is a story of energy and entropy, creation and destruction. Even now, with all the tools of modern astronomy, mysteries remain. There are stars whose masses and lifespans defy tidy explanation. Some, known as magnetars, possess magnetic fields so powerful they could erase a credit card from halfway to the moon, their surfaces racked by starquakes and bursts of high-energy radiation. Others, called pulsars, spin hundreds of times per second, sweeping beams of radiation across the cosmos like lighthouse beacons. The full catalogue of stellar phenomena seems to expand each decade as new instruments peer deeper into space and time. And then there are the so-called failed stars, the brown dwarfs, bodies too massive to be planets, but too slight to sustain full fusion. These lurk in the galactic shadows, glowing faintly in infrared, as if forever caught at the threshold of true stardom. Each of these entities, dwarfs, giants, pulsars, and the rest, are united by the same fundamental physics. It is the interplay of gravity and pressure, fusion and collapse, that gives rise to such variety. Yet the details are rich and subtle, shaped by chance and environment, leading to outcomes both predictable and surprising. If you were to voyage close to a star, the gentle twinkle would vanish, replaced by a ferocious glare. The surface of a star is not solid, but a seething plasma, its atoms stripped of electrons, its structure shaped by currents of magnetic force and the constant churning of convection. Sunspots and solar flares, visible even on our own sun, are the visible scars of this tumult, evidence of the dynamic and sometimes violent life of a star. Through spectroscopy, the study of starlight split into its component colors, astronomers have learned to read the fingerprints of elements within stars, to measure their speeds, and to estimate their ages. Each absorption line, each subtle variation in hue, tells a story of temperature, motion, and composition. Yet for all we have learned, there are puzzles yet unsolved. How do the largest stars shed so much mass, sculpting vast nebulae with their winds? What triggers the sudden collapse of a core into a neutron star? What new kinds of stars might exist beyond the reach of our current instruments? The universe, it seems, delights in complexity. It offers up not answers, but invitations, questions that entice us ever onward, deeper into the heart of the unknown. And so as you rest beneath the silent watch of the stars, remember that their serenity is a performance, their steadiness the product of constant, furious change. They are not mere ornaments, but engines that shape the fate of galaxies, create the very atoms in our bones, and illuminate the void with their ancient, unending dance. Their ballet continues, unseen and unceasing. In the next moment, as your mind drifts in the half-light between waking and sleep, linger with the knowledge that every star is both a beacon and a question, burning not only with light, but with mystery. For beyond the known, at the farthest frontiers of science, there are yet more wonders waiting to be revealed, and more stories waiting to be told. The night sky stretched above us in quiet immensity has always beckoned the attentive gaze. For much of human history, we were limited to what our naked eyes could glean, dots of light scattered in patterns across the darkness, whispering of distances and stories beyond our reach. Yet there came a time when curiosity, that tireless companion of our species, demanded more than simple wonder. It asked for clarity, for definition, for the power to see further and deeper into the cosmic sea. And so the slow unveiling of the universe began, not merely with new eyes, but with new instruments fashioned by human hands. In the early years of the 17th century, as Europe trembled on the edge of scientific revolution, a humble instrument changed everything. The telescope, a tube of glass and metal, simple in appearance, yet profound in implication, was first pointed skyward. Galileo Galilei, that restless observer from Pisa, took up this device, originally intended perhaps for terrestrial pursuits like navigation or warfare, and directed it toward the heavens. Through its lens, the moon revealed itself as a world of craters and mountains, not the smooth celestial orb philosophers had long imagined. Jupiter, once a solitary light, displayed its retinue of 4 dancing moons, Io, Europa, Ganymede, and Callisto, moving in stately procession around their giant lord. Galileo's observations shattered the crystal spheres of the ancients, casting aside the notion that the heavens were immutable and perfect. The telescope in those early trembling years was not just an extension of the eye. It was a new way of knowing, a bridge between the finite and the infinite. With each refinement in lens and mirror, humanity's view of the universe sharpened. More stars became visible, hundreds, then thousands, then millions, each a sun in its own right, scattered across the vastness. Over the centuries, telescopes grew in size and sophistication. The reflecting telescope, pioneered by Isaac Newton, replaced glass lenses with curved mirrors, banishing the rainbow smears of chromatic aberration and gathering light with ever greater efficiency. On the windswept moors of Britain, in the quiet woods of America, and atop the mountains of Europe, great observatories began to rise, their domes gleaming in sunlight and moonlight alike. The astronomers who worked within them became explorers of a new kind, navigators of the night. Yet, seeing light alone was not enough. The true riches of the stars are carried not only in their brightness, but in the subtle messages hidden within their rays. Here another instrument arose, the spectroscope. Light, when passed through a narrow slit and then a prism or diffraction grating, unfurls into a spectrum, a rainbow band, delicate and continuous. But the spectra of stars are not merely rainbows. They are inscribed with dark lines, tiny notches at specific colors, each a signature left by the atoms within the stellar furnace. Gustav Kirchhoff and Robert Bunsen in the mid-1800s realized that these lines, now called absorption lines, were like fingerprints. Each element, whether hydrogen, sodium, or iron, imprints its own pattern upon the light. Through the patient study of spectra, astronomers could, for the first time, decipher the chemical composition of stars. The sun, it turned out, was not made of some exotic celestial matter, but of elements familiar from earthly laboratories. The universe, in all its grandeur, was built of the same basic stuff. This realization marked a profound shift. No longer were the stars distant mysteries, forever beyond our touch. They became knowable, their secrets written in codes of light and color. The spectroscope, and later the photographic plate, allowed astronomers to collect and preserve these codes, to study them at leisure, and to compare the spectra of countless stars and nebula. The sky became a laboratory, and the universe a subject for experiment. In the early 20th century, as photographic technology improved, the astronomer's reach extended further still. Henrietta Swan Leavitt, working at the Harvard College Observatory, pored over plates of variable stars, tiny dots that brightened and dimmed with cosmic regularity. From her meticulous work arose the period luminosity relation for Cepheid variables, a discovery that would become a yardstick for measuring the universe itself. Edwin Hubble, drawing on Leavitt's insights, peered through the immense Hooker telescope on Mount Wilson and found that the spiral nebula were not gas clouds within our own galaxy, but island universes, galaxies far, far beyond. Yet the most transformative revelations were still to come, hidden within the subtle shifts of color in starlight. When a star or galaxy moves toward us, its light is compressed, nudged slightly toward the blue. When it recedes, the light is stretched toward the red. This phenomenon, known as the Doppler shift, was first described for sound waves by Christian Doppler, but soon found profound application in astronomy. It was Vesto Melvin Slipher, working in the quiet of the Lowell Observatory, who first noticed that the spectral lines of distant nebula were not where they should be. Most were shifted toward the red, indicating that these objects were racing away from us at tremendous speeds. Edwin Hubble, assembling these redshifts into a coherent map, discovered that the farther a galaxy lay from the Milky Way, the faster it appeared to recede. The universe, it seemed, was not static and eternal, but expanding, growing larger with every passing moment. This insight, born from the patient measurement of faint spectral lines, forever altered our understanding of the cosmos. The Doppler shift became a key, unlocking not only the motions of galaxies, but the history and fate of the universe itself. the echo of the Big Bang, the notion that all things once sprang from a single incandescent beginning, was written not in myth or legend, but in the subtle red tinge of distant starlight. As the 20th century advanced, the tools at astronomers' disposal multiplied and evolved. Where once the eye and the telescope sufficed, now the full spectrum of electromagnetic radiation was brought to bear. Radio waves, microwaves, infrared, ultraviolet, X-rays, gamma rays, each revealed new facets of the universe hidden from ordinary sight. Karl Jansky, listening for static on a radio antenna, stumbled upon the hiss of the Milky Way. Jocelyn Bell Burnell, scanning miles of chart paper, discovered the rhythmic pulsing of a neutron star. Infrared telescopes, cooled to frigid temperatures, peered through clouds of dust to glimpse the birth of stars. X-ray observatories, lofted above the atmosphere, recorded the furious outbursts of black holes and neutron stars. The atmosphere itself, once a friend and protector, became a barrier to further progress. Its turbulence blurred the finest images, and its molecules absorbed or scattered much of the high-energy light from space. To overcome these limits, astronomers looked upward, not just with their eyes, but with their machines. Balloons, rockets, and satellites carried telescopes above the clouds into the clarity of space. Among these, the Hubble Space Telescope became a symbol of a new era. Launched in 1990, it escaped the shimmering haze of Earth's atmosphere and opened its unblinking eye upon the universe. With it, astronomers gazed deep into the past, seeing galaxies as they appeared billions of years ago when the cosmos was young. The iconic Hubble Deep Field, a tiny patch of sky imaged for days on end, revealed thousands of galaxies in what had seemed an empty void, each a swarm of suns, each a world of possibility. But even Hubble, for all its precision, sees only a narrow sliver of the electromagnetic spectrum. To capture the full story, a fleet of specialized observatories joined the quest. Chandra for X-rays, Spitzer for infrared, Fermi for gamma rays. Each brought new images, new data, new enigmas. The universe, it turned out, was not only vaster than we imagined, but stranger. There were jets of matter launched at near light speed from the hearts of galaxies, clouds of hydrogen glowing gently in the radio, and the afterglow of the Big Bang itself, the cosmic microwave background, a whisper of heat from the dawn of time, mapped in exquisite detail by satellites like COBE, WMAP, and Planck. The methods of astronomy, too, have grown ever more subtle and powerful. Light is not merely collected, but dissected and analyzed by computers, algorithms parsing billions of photons to tease out patterns invisible to the human eye. Adaptive optics, a marvel of engineering, bends mirrors in real time to correct for the atmospheric blur, allowing earthbound telescopes to rival the resolution of those in space. Interferometry, the art of combining signals from widely separated telescopes, creates virtual instruments as large as the Earth itself, capable of imaging the event horizons of black holes. With each advance, the questions deepen. We now measure the wobbles of stars to detect the faint tug of orbiting planets, infer the presence of dark matter from the motions of galaxies, and listen for the faint ripples in space-time, gravitational waves set loose by colliding black holes. The cosmos, once a silent panorama, now sings to us in 1,000 voices. Yet, for all these wonders, the tools of the astronomer remain at their heart instruments of humility. They remind us that we are small, perched on a minor planet, circling an ordinary star in a vast and ancient universe. But they also offer hope, the hope that through patience and ingenuity we can unravel the threads of the cosmic tapestry, one observation at a time. The journey is far from finished. New telescopes are rising on the ground and in orbit, each promising sharper vision, deeper reach, and new mysteries. The James Webb Space Telescope, with its golden mirrors and delicate sun shield, has already begun to rewrite our understanding of the earliest galaxies and the atmospheres of distant exoplanets. Arrayed alongside it, radio dishes as large as city blocks, gamma-ray detectors riding high-altitude balloons, and gravitational wave observatories listening for the faintest tremors of space-time, all are poised to open new windows on the cosmos. The stars themselves, once thought to be immutable and distant, have become dynamic laboratories. We watch as they are born in clouds of gas, blaze with nuclear fire, and die in titanic explosions, scattering their elements into the interstellar night. Through our tools, our methods, and our restless curiosity, we begin to glimpse the intricate weave of the universe, the connections that bind the smallest atom to the largest galaxy, the patterns repeating from the microcosm to the macrocosm. Yet even now, as our instruments grow ever more precise, there remain shadows on the cosmic canvas, dark matter, dark energy, the true nature of black holes, and the fate of the universe. Each discovery, each observation, is both a revelation and an invitation, a call to look further, to think deeper, to wonder anew. Somewhere, in the stillness between stars, new questions are waiting to be asked. The tapestry is vast, its threads uncountable, and the story, as ever, continues to unfold. In the gentle hush that follows a night spent in contemplation beneath the stars, a different kind of awareness sometimes dawns, one less concerned with the temperature of stellar cores or the intricacies of fusion, and more with the quiet, persistent question that has haunted human minds for as long as our eyes have turned skyward. What do the stars mean to us, not just as objects of science, nor as distant fires, but as beacons that illuminate the corridors of our own existence, casting shadows and light on the mysteries of being itself? For millennia, before the language of atoms and spectra, before telescopes ground their glassy eyes to clarity, before even the first myths were spoken around the embers of ancient fires, the stars entered our awareness as patterns, constellations traced not only on the skin of the sky, but upon the fabric of our minds. These clusters of bright points became stories, woven into the tapestry of culture and memory. Orion, the hunter forever stalking the heavens, Cassiopeia, the vain queen, Scorpius, curling its tail against the dark. Every culture found its own stories, its own heroes and monsters, its own lessons written in light. In those stories, humanity found comfort and guidance. The stars became calendars, marking the passage of seasons. They became compasses, guiding sailors across trackless oceans. They became omens, auguring the fates of kings and the rise of empires. Yet, behind these practical and mythic uses, there was always a deeper wonder, a sense that the stars, in their unreachable distance, might yet be connected to the fate of those who gazed upon them. As our understanding sharpened, as the tools of science unspooled the threads of myth, a new and even more profound connection was revealed. The stars, it turned out, were not merely distant fires, but ancestors in a very literal sense. The atoms that make up our bodies, carbon in our cells, calcium in our bones, iron in our blood, were not born on Earth, but in the hearts of ancient stars. In their dying throes, as supernovae scattered the ashes of their brilliance across the galaxy, those atoms became the raw material for planets, oceans, and living things. When the astronomer Carl Sagan spoke of us as star stuff, it was not a metaphor, but a precise description of our material heritage. This realization that we are made of the same stuff as the stars transforms the night sky from a distant spectacle into a kind of mirror. In the darkness, we see not only the history of the cosmos, but the story of ourselves. The hydrogen in our water, so simple and light, was forged in the first seconds after the Big Bang. The heavier elements, the building blocks of complexity and life, were brewed in stellar furnaces, scattered by cosmic winds, gathered into clouds that coalesced into new stars and planets, and finally into thinking creatures able to ponder their origins. To understand this, to feel it in the marrow, is to experience a kind of kinship with the universe. The stars are not strangers, but relatives. They are the ancient forges that made possible the very thoughts we use to contemplate them. From this perspective, astronomy becomes not only a science, but a kind of genealogy, a search for roots that reach back billions of years and span light years of space. Yet if this connection grants us a sense of belonging, it also brings with it a vertiginous awareness of scale. The distances between stars are so immense that even light, the fastest thing in the universe, takes years or centuries to bridge them. The age of the stars dwarfs all of human history. The Sun, middle-aged at 4.6 billion years, is itself a newcomer compared to the oldest stars in the galaxy. Our lifespans, measured in fleeting decades, are but sparks in the cosmic night, and beyond the stars we can see, there stretches the vast inky ocean of the universe, hundreds of billions of galaxies, each containing hundreds of billions of stars. The numbers boggle the mind, and with them comes a kind of humility. In the face of such immensity, the dramas of our daily lives seem, at first, to shrink to insignificance. Yet paradoxically, it is precisely our awareness of this vastness that makes our own consciousness so precious. Against the backdrop of the cosmic void, the very fact that we can reflect, reason, and wonder is a rare and luminous thing. Throughout history, this sense of awe has shaped not only our sciences, but our philosophies, our art, even our moral sense. The stars have been taken as symbols of permanence, constancy, and aspiration. The ancient Greeks, seeking order in the heavens, gave rise to the first systematic cosmologies. The medieval astronomers, charting the motions of wandering planets, laid the groundwork for the scientific revolution. Each generation, in its turn, has looked to the stars and found in them a challenge to understand, to explore, to imagine. Perhaps no transformation has been more profound than the shift from a geocentric to a heliocentric view, from a universe that revolved around the Earth to one in which our planet is but one among many, orbiting an ordinary star in an unremarkable corner of the galaxy. This realization, so unsettling to some at the time, has become a touchstone for humility and curiosity alike. It reminds us that our sense of centrality is often an illusion, and that the true adventure lies in seeking our place within a cosmos far grander than we could have dreamed. And so the study of stars has become, in a way, a study of ourselves, not only in terms of our physical origins, but in the unfolding of our intellect, our curiosity, our capacity for wonder. When we peer through telescopes or launch probes toward distant worlds or decode the spectra of far-off suns, we are participating in a tradition as old as humanity, the desire to know, to reach beyond the boundaries of the known, to find meaning in the endless night. Yet the stars also confront us with questions that science alone cannot answer. Are we alone in this vastness? Is consciousness a rare flicker, or does it blaze in myriad forms across the galaxy, waiting to be discovered? The search for life beyond Earth, whether in the frozen oceans of Europa or the shadowy atmospheres of exoplanets, is as much a philosophical quest as a scientific one. It asks us to reflect on the nature of life, intelligence, and the possibility of communication across gulfs of space and time. In pondering these questions, we are drawn once more into the realm of myth and meaning. The constellations, once gods and heroes, now become markers of possibility, signposts on the road to an unknown future. As our instruments grow more powerful, as our reach extends beyond the Earth, we find ourselves at the threshold of a new relationship with the stars. One not just of observation, but of participation. Already human hands have sent machines beyond the cradle of Earth, the Voyager probes, bearing messages in the languages of mathematics and music, drift silently between the stars, ambassadors of a tiny world. Astronomers map the atmospheres of exoplanets, searching for the fingerprints of biology. Engineers dream of fusion engines and solar sails, of journeys that might one day carry us to other suns. What will it mean in the centuries to come to become a spacefaring species? How might our myths and philosophies change when the stars are not only objects of distant wonder, but destinations? Will we carry with us the old stories, or will new constellations be drawn, new narratives woven among unfamiliar skies? Perhaps, as we set foot on alien worlds, we will find ourselves on, see again, looking upward, tracing patterns in unfamiliar heavens, seeking meaning in the dance of distant lights. And as we reach outward, there are deeper questions yet. In mapping the stars, in deciphering the language of light, we have learned to read the history of the cosmos itself. The universe, it seems, is not timeless, but has a story, a beginning, an evolution, perhaps even an end. The light we see tonight from a distant galaxy is an ancient message, a record of what was, carried across eons. In this light we glimpse the birth and death of stars, the swirling of galaxies, the slow drift of cosmic time. Yet for all our knowledge, the stars remain a source of mystery. There are things we do not yet understand. The nature of dark matter and dark energy, the fate of the universe, the possibility of multiverses beyond our own. Each answer uncovers new questions. Each discovery hints at deeper layers of reality. In this sense, the stars are both the oldest and the newest of mysteries, forever receding before the advance of our understanding, forever inviting us onward. There is a quiet beauty in this endless pursuit. To study the stars is to accept that we will never know everything, that the universe is larger and stranger than our minds can fully grasp. It is to embrace uncertainty, to find solace in the unknown, to cherish the questions as much as the answers. In this way, the night sky becomes not a backdrop to our lives, but a living canvas painted with the colors of our curiosity and hope. And so, as you lie beneath the stars, or imagine them glowing softly above the ceiling of your room, you join a lineage stretching back through uncounted generations. You become part of the story the stars have always told, a story of origins and endings, of wonder and doubt, of minds reaching out into the darkness, searching for connection and meaning. The constellations above are not only maps of the heavens, but maps of the human heart, charting the places where imagination meets infinity. Perhaps in the quiet hours you sense the stirrings of that ancient longing to know, to belong, to touch the unreachable. The stars, silent and remote, answer not with words, but with light, a light that has travelled across ages to reach your eyes. In that light is written the history of worlds, the echoes of ancient fires, the promise of futures yet unimagined. One day, perhaps, our descendants will stand on distant worlds, beneath alien constellations, and look back toward our own sun, a pale point among billions. They will ponder their own origins, their own place in the great unfolding. And perhaps, as they do, they will remember that all journeys begin with a question, and that every answer leads onward into deeper darkness, richer wonder. So tonight, let your mind drift among the philosophical constellations, tracing the lines that connect not only the stars above, but the thoughts within. The study of the stars is the study of possibility, of humility, of hope. It is the quiet recognition that in a universe vast beyond measure, to be conscious at all, to wonder, to seek, to dream, is itself a kind of miracle. As the night deepens and the stars wheel slowly overhead, unresolved questions linger like soft echoes in the mind's quiet spaces. The constellations remain, marking the passage of time, inviting you to follow their stories onward into the boundless sea of night. And so our journey among the stars gently drifts to a close, like a comet tail fading into the hush of space. May your thoughts float softly on cosmic breezes, carrying you to peaceful dreams until we meet again for more whispered mysteries beneath the night sky.